Alright, so last section for the prerequisite chapter in pre-calc. So this unit's test will be over section 6, 7, and 9. We're going to skip 8 for pre-calc. So this one will probably be a little longer. I'm going to try to keep it short. We're talking about interval notation and then inequalities, linear, compound, and absolute value inequalities. First thing when we talk about interval notation, it's going to be how we write our answers with regards to absolute values. And what we need to remember is that parentheses don't include, and that's going to be usually when we have the symbols less than and greater than. Okay, brackets do include, and that's going to be less than or equal to and greater than or equal to. Okay, we can also have a mixture of the two. We could have a parentheses 3 and then bracket 6. This would mean that solutions are all values of x that are less than or equal to 6, and we say less than or equal to because of the bracket, and also greater than 3. So if our inequality had a solution like this, we could write it in interval notation like this. And changing these symbols would just change the parentheses and the brackets appropriately. So when we have a to infinity, this doesn't include a. So this would be, an example here would be x is greater than a. Okay, if we change this to a bracket, then it would be x is greater than or equal to. Oops, that should be x is greater than or equal to a. And so intervals or brackets and parentheses just have to do with interval notation and other ways that we can write our solutions besides the typical inequality solutions that we've written in the past. Alright, so a linear inequality is just going to be an inequality that has like an equation. We just have one of our symbols, less than, greater than, less than or equal to, or greater than or equal to instead of an equal sign. We're going to solve it just like a linear equation. The only thing we need to keep in mind is that when we're multiplying or dividing by a negative, we need to switch the symbol. So two examples for that. Then I'm going to start by subtracting 2 from both sides, which is going to leave me with a negative 3x is less than or equal to 3. And then I need to divide by negative 3, which is going to leave me with x, and 3 divided by negative 3 is 1. But here's where we need to be careful. Because we're dividing by a negative, we're going to switch the symbol. And I don't mean the sign, I mean the inequality symbol. So we'd say this is x is greater than or equal to 1. Okay, we could also graph that. So if we put our number line here, arrows on both ends, if I say 0, 1, negative 1, 2, I can put more, but I don't need to. Greater than or equal to tells us to use a closed circle. And the other option would be just less than or just greater than, and we'd have an open circle. But here, since it's greater than or equal to 1, we're going to shade one direction. Okay, another example over here then, you notice we have variables on both sides. So I'm going to start by subtracting x from both sides. And that's not the only way to start, it's just how I'm going to do it. So we end up with negative 3x minus 4 is greater than 5. We add 4 to both sides, which leaves us with negative 3x is greater than 9. And finally, we divide both sides by negative 3. Again, dividing by a negative tells us to switch the symbol. And so we have x is less than 3. Drawing my number line then, if I'm going to graph that, put my arrows on the ends. I'm just going to say 0, and then negative 3. Since it's just less than, now we put an open circle and we shade the less than values. Okay, so closed because it doesn't include, open because it doesn't include, closed because it does include, because it's also the possibility of equal to. So probably make sure to make a note of that if you don't remember that from when we've done these in the past. Then we're going to have what are called compound linear inequalities, and these are going to be inequalities that have two conditions, and that means that there's an and or an or statements. We perform operations on all sides, meaning there's 1, 2, 3 sides. So thinking about it like an equation, if we draw a line down our equal sign, now we need to think about having multiple lines, and we could have this one as well. Now both the examples that I have here are compound and inequalities, meaning it has to satisfy both conditions at once. we also have what are called compound OR inequalities that would actually be written as two separate inequalities with the statement OR in between them. To start here, we're going to subtract 1, but remember we need to perform operations on all sides, so I'm going to subtract 1 from all three sections, which is going to leave me with negative 4 is less than just 2x now, and is less than or equal to 2. Again, I'm dividing by 2, and I need to do that on all sides. And so that's going to give me that x is less than or equal to 1 and greater than negative 2. So negative 2 is less than x is less than 1, or less than or equal to 1. And if I draw my line so that I can graph this, I'm going to put 0 on there, I'm going to put 1 on there, and then negative 2. Okay, open circle at negative 2, closed circle at 1. And because it's an AND statement, that means I'm going to shade in between them. And looking at our other example, I start the same way. I'm going to do things to all sides. So I'm going to end up with negative 2 less than or equal to 2x less than or equal to 8. Divide each piece by 2, and I end up with x. And so I'm going to have negative 1 is less than or equal to x is less than, this should just be less than 4. And finally then if I graph that, and here we go, put my 0, I'm going to put negative 1 and 4, open circle at 4 this time, closed circle at negative 1, and I shade in between them because it's an AND statement. If it was an OR statement, we would be shading outside of them, so not between them. Hey, last piece then, if we have an absolute value inequality, so this is the piece that tends to give us a little bit of trouble. This is just going to be an inequality where we have an absolute value, meaning the variable is inside the absolute value, and it's going to essentially create a compound inequality. So if our absolute value with our variable inside, and it could be more than just an x, it could be a 2x plus 6, is less than c, that's going to tell us to make an AND statement. So the piece inside the absolute value is in between the positive and negative c. And if it's greater than c, then that tells us to make an OR statement. Either x is less than negative c or x is greater than c. So the top one here, we're going to shade between when we graph our solution, and the bottom one here we shade outside when we graph our solution. Okay, so a couple examples of that. The first one we have is less than 3. So that is going to tell us, remember, if I jump back here, if it's less than, that's an AND statement. So less than, we need to bring down our expression, stays less than 3, and is greater than negative 3. So I solve this just like I did a compound now. I'm going to add 4 to each side, which leaves me with x in the middle. It leaves me with 1 over here, and it leaves me with 7. So 1 is less than x is less than 7. And we again can graph that. I'm just going to put 1 and 7. What am I doing there? Just going to put 1 and 7, and these are both open circles. And because it's an AND statement, we shade in between them. And look at the second one, you need to be careful. Make sure you isolate first. So we subtract 7 from both sides. So we have negative 2 times the absolute value of 3x plus 5 is less than or equal to negative 20. And now we need to divide by negative 2. So the absolute value of 3x plus 5, remember when we divide by negative, we flip our symbol, and so we get positive 10. And this is the case now because it's greater than, we're going to make an AND statement. So 3x plus 5 is greater than or equal to 10. And I'm sorry, we don't make an AND statement, we make an OR statement. Or 3x plus 5 is less than or equal to negative 10. Okay, solving each one independently now. So I'm going to start by subtracting 5 on this left one. And that'll leave me with 3x is greater than or equal to 5. And then dividing both sides by 3, that leaves me with 1 2/3 or 1.67, greater than or equal to. Same idea, we start by subtracting 5, so we're going to have the same steps, but we're going to have different solutions this time. So 3x is less than or equal to negative 15. Dividing by 3, I get that x is less than or equal to negative 5. So remember, in OR statement, we do not shade in between, we shade outside. So if I have 0 in the middle, 1, 2, and then let's see, negative 1, negative 2, negative 3, negative 4, negative 5, and they're both closed circles now, so I'm going to put a closed circle at negative 5, put a closed circle at 1 2/3, so we want greater than or equal to 1 2/3, shade to the right, less than or equal to negative 5, so I shade to the left. So you notice when it's an OR statement, they're going to go in opposite directions. So that is it for this lesson. We're going to have a challenge question. I will give 5 points bonus if I'm going to collect a sheet of paper at the beginning of class showing that you did this correctly or not. This will be worth, like I said, 5 points bonus. And then tomorrow and probably for the next 2 days, we will do sessions. We will spend working with our various inequalities and absolute value inequalities. See you next time.